Now for the last part, we've got to find the distance between the 2 points at which the particle P is instantaneously at rest. And in the previous part we found out that it was instantaneously at rest when t was equal to 2 and when t was equal to 6. And I also showed you that towards the end of that video, not that it was asked, but I went through the motion of the particle as we went from t equals 2 to t equals 6 and beyond actually. So now in the last part of the video I went through the motion of the particle P. I showed you that, okay, we had it starting at this point, say when t was equal to 0. Let's just say that point was there. And when t was equal to 0, I made no assumption at whereabouts it was to a fixed point. Let's suppose this is our fixed point, O. Well, when t equals 0, it could have been, say, here. But then it moved to the right, and after 2 seconds it stopped. It was moving at 6, slowed down, 2 seconds later it stopped. So this is at t equals 2, it was here. Then it reversed direction and headed backwards until after 6 seconds it was somewhere else. Let's just say it was here, t equals 6. And then it turned round again and then shot off to the right. So when we're trying to work out this distance between the two particles when it's at instantaneous rest, I really want to figure out where it is, what that displacement is from a fixed point O, say, when t equals 2. Let's call that, say, S at t equals 2, S2. And then I want to work out what that displacement is when t equals 6. So we'll say that's from here to here, and that is S6, okay, that distance there, S at 6. So to get that distance I just need to do S2 minus S6. Now to get displacement we should be familiar with the fact that you have to integrate v, the velocity, with respect to time. So that's our starting point, okay? We're just going to look at S. S is going to be, in general, the integral then of v with respect to time. And if we substitute what we've got in then for v, we've got t squared over 2 minus 4t plus 6. We're integrating all of that, so hence the brackets there, with respect to time. Now if we integrate this in the usual way, we add 1 to the power, divide by the new power, so we get t cubed over 3, times it with the 2, and you get t cubed over 6. So t cubed over 6. And then for this one we've got minus 4, add 1 to the power, so you've got t squared, and divide by it. And then for the last term here, plus 6, constant, just put a t on the end. And we mustn't forget that constant of integration, let's say plus c. Now we don't have any conditions that allow us to work out what c is. We don't know what s is when t equals 0. But we're interested in the time t equals 2, so we can find out what s2 is. So let's start by saying when t equals 2. Now when t equals 2 we get S2. S2 is going to be 2 cubed, which is 8, divided by 6. Let's just put 8 6 there. And for this one, well, we can actually cancel that 2 into the 4, goes twice. So when we have t equals 2, we've got 2 squared is 4, times that 2 is 8. We've got minus 8 then. Here we've got plus 6 times 2, which is 12, and then plus the constant of integration c. So if we work this out, okay, it comes to 16 over 3, 16 thirds plus c. Let's just put it on the end here, 16 thirds plus c. Now we need to work out what the displacement is now when t equals 6. S6 in other words. So we can say that when t equals 6, S6 equals, and just substitute 6 into here, okay, and we've got 6 cubed over 6, so put that down, 6 cubed over 6, minus 2 times 6 squared, minus 2 times 6 squared, and then plus 6 times another 6, that's 6 squared again, and then plus c. And working this out, well, we've got 6 squared here actually, 6 squared plus another 6 squared, that's 2/6 squared, and we've got minus 2/6 squared, so this comes to 0 plus c. So we can now get that distance, let's just put it in here, between the particle when it's at instantaneous rest. It's going to be S2 minus S6, S2 minus S6. And what does that equal? Well, we've got 16/3 plus c, and then we just need to subtract c here. 0 plus c is simply c. Then c's cancel, we're left with 16 over 3, 16/3, or 5 1/3 meters. The distance then between where the particle comes to instantaneous rest. Okay, well, I hope that's given you some idea now how to go about that question.